We present projective displacement mapping for ray-traced editable surfaces. We explore the problem of authoring detailed geometry over a low polygon base mesh while ray tracing for visual feedback. With our method, displaced surfaces are edited and rendered interactively while using displacement brushes. Lighting is fully controllable and exhibits soft shadows, environment lights, and global illumination. Reflections show displaced features in neighboring objects. Starting with a low-resolution base mesh, we ray trace detailed surfaces at high quality with zero tessellation. Our method constructs prisms with positive and negative stents around each triangle. Utilizing a hardware BVH for top-level acceleration, we forego a bottom-level acceleration structure to avoid data structure rebuilds per frame and costly traversals per ray. For projective displacement mapping, we show that the barycentric coordinates of offset triangles corresponds to the interpolated normals of the displaced surface. Here we visualize the algorithm as it proceeds through one or many prisms. The goal is to find the hit point of the displaced surface for a given ray. Ray samples are projected through interpolated normals using the barycentric coordinates of scanning triangles. While projective displacement mapping is a direct ray marching method, we achieve high quality for modest sample spacing by introducing smooth displaced normals, stochastic sampling for thin features, tight BVH prism bounds, and accelerated ray bilinear patch intersections. We validate our method with a ray-traced reference implementation on the CPU and make this code available open source. Our method supports interactive editing of displaced surfaces, resolving to full resolution on mouse release. Artists can add the finest details, as there are no LODs, up to the adjustable displacement depth. Sculpting while ray tracing allows artists to design and visualize features on objects such as this fur torus with details that are not achievable by other editing techniques. Where uniform tessellation would require many gigabytes for equivalent quality, we require only a few additional kilobytes over the base mesh and displacement texture. The prism overhead is just 108 bytes per base triangle. We achieve good performance at over 100 million rays per second, even for small, high-quality sample spacing. Better visual results are achieved without C1 intermediate surfaces by using our novel technique for smooth displaced surface normals. Offline ray tracing is also greatly accelerated by our technique. Projective displacement mapping achieves faster performance with our incremental scanning technique over a top-level BVH than other methods using a bottom-level acceleration structures such as min-max, mipmaps, or primitive BVHs. Here we demonstrate a scene of many objects without displacement and 3 levels of refraction that requires 84 milliseconds per frame sample. For this scene, our technique can interactively render displaced geometry on all objects in only twice the time. Offline ray tracing with 64 samples per pixel requires just 12 seconds per frame. This seahorse was modeled from scratch using our interactive editor with multiple displacement brushes. While sculpting, the model is fully ray traced with global illumination, diffuse reflections, environment maps, and soft shadows, providing valuable feedback to artists as they work. Brushes consist of 256 square pixels, which are blended in real time into 6400 resolution displacement and color texture targets. A region around the mouse cursor is ray traced immediately, while the full image is rendered on mouse release over many sample frames. Lighting, surface properties, and materials can be fully dynamic.